Okay, so what we're going to do today, we've been practicing factoring, right? Factoring quadratic trinomials and factoring binomials, quadratic binomials that are differences of two squares, right? Two squares, two perfect squares with a subtraction sign in between, right? So you guys know how to factor those, but you don't know why you're doing this, what it actually tells you. It tells you a ton of stuff, or it tells you important information. But up to this point, I've only been giving them to you as expressions, not as equations, right? There's not been any equal sign, it's just been a trinomial and you've been factoring it, right? Now we're going to put it all together. We're going to put it into an equation and we are going to see what it actually tells us, okay? So first of all, I'm just going to draw a graph for a second over here just because I'm going to be using it periodically to talk about. And so the title of the lecture is called Finding the Zeros, or Finding the Roots, or Finding the Solution, or Finding the x-intercepts. Those are all exactly the same thing. Seems like why would they have four different, I have no idea. Why would they have four different ways to say the same thing? But they do. Finding the zeros is the one you're most likely going to hear in algebra. But it could also be finding the x-intercepts or finding the roots. Roots are like factors, right? Like the roots of 4 is 1 and 4 and 2 and 2, right? Those are your roots of 4. Those are your factors of 4. So when you factor a trinomial, you know, and you have like x squared minus 16. You have x plus 4 times x minus 4. The x plus 4 is one of the factors, right? And x plus 4, isn't this exciting stuff? Are you excited? Like, I can tell you were very excited. Yes. Okay, but it's like those are the factors, right? Those are the roots of the equation, right? So you can't get roots unless you factor, okay? But usually finding the zeros is what you're going to see. But you have to kind of know that all of this is what they might be asking. So what does it mean to say find the zeros? When they use this term find the zeros, this is what it means. It means this: find x when y is 0, right? So if I gave you an equation like this, y is equal to x squared plus, let me think, let's see, 8x plus 15. And I asked you to find the zeros. That means find the x's, right, when y is 0. I care about when y is 0, where does my parabola cross the x-axis? That's what it's telling you. It's telling you where that parabola is crossing the x-axis. So, really fast, Thorin, help me factor this equation. So I'm going to say y is equal to what?
X plus 4, or no.
Factors of 15.
3, so plus 3.
Okay, plus 3 and plus 8, right? I mean plus 5, sorry. Yes. Okay, so now suddenly we factored it, and we have y is equal to this factored thing. But it says find the zeros. That means when y is 0, I want to find where the x crosses. So instead of having y now, I'm going to replace y with a 0, okay? Now, I'm going to put my 0 on the other side, just because I like that. X plus 3 times x plus 5 equals 0. Okay? You guys with me? It's pretty easy, but you just have to get this one basic piece of information. There is a rule in algebra. All right? And this is the rule. I'm going to write it right rule. Says if A times B equals 0, then either A equals 0 or B equals 0. If A times B equals 0, then either A equals 0 or B equals 0. Is that true?
Yeah.
I mean, really, can you think of any exception? Like, if you, one number times another number that's not, neither is 0, can you get it to equal 0? Is there any way to get it to equal 0 if neither of the two numbers are 0? Not really, right? You can get 0.0000000000001 times 0.0000000000001, right? And it would be very little, but it would still not be 0, right? The only way you can get to 0 is if it was one of them was 0 at least. Maybe two of them, maybe both of them are 0, right? But at least one of them has to be 0, right? Does that make sense? Now, this is the same idea. A, this is my A, this is my B. A times B equals 0. So that means that either x plus 3 has to equal 0. Do you agree with me? Right? Do you see what I'm saying? Either x plus 3 has to equal 0 or x plus 5 has to equal 0. How would x plus 3 equal 0? What would x have to be?
-3.
Right. So x could be -3, right? And then it would equal 0. What would this have to be? -5. So if you did it algebraically, you can either do it that way in your head, or you can say, well, x plus 3 equals 0, and then you write the word or, and then you say x plus 5 equals 0, and then you subtract 3 from both sides, right? And you get x is equal to -3, and then subtract 5 from both sides, x equals -5. And that's what you got when you said, oh, well, x would have to be -3 here. Ah, x is -3. X would have to be -5 here for that to be 0. X is -5. So my zeros are -3 and -5. Over here, I've got 1, 2, 3, 4, 5. I know that my parabola crosses the x-axis at those two places. That immediately, what does it tell me? How is that useful?
Well, it gives you your parabola, so you could just.
It shows you kind of where the parabola is going to be, right? Doesn't it? I mean, I pretty much know. Do you know where the axis of symmetry is likely to be?
Yeah, it's gonna be right below that, right?
Well, axis of symmetry is a vertical line, right, that goes everywhere, right? So where, I mean, it goes up and down, straight up and down, right?
It's
Forever.
gonna be in the middle.
When we know the vertex is going to be on that line, where's that line going to have to be in relation to those two dots?
In the middle.
Right smack in the middle, because a parabola is symmetrical, right? You see what I'm saying? So suddenly, you got these two dots, that's -3 and that's -5. What's the dot in between? -4, right? That's where my axis of symmetry is going to be. Does that make sense? You see that? Right? So, and I have it, and is this going to be a happy face or a sad face? Happy, positive, happy, right? And I know basically that my parabola is going to look something like this, right? So I don't know exactly where it's going to dip down here. I'd have to figure that out, right? I'd have to find my vertex. Remind me, how do you find your vertex?
X equals -b over 2a.
Right, and that gives me what of my vertex?
The axis of symmetry.
That gives me my axis of symmetry, which is my x of my vertex. But how would I find my y of my vertex?
You would plug in -4, for instance, right?
Right, exactly. You plug in, if that's going to be your vertex, right? I mean, your axis of symmetry, -4, then you plug that into this, and you get that, right? So x equals -b over 2a. -8 over 2 times 1. -8 over 2 is -4. Look at that, -4. We did it, right? So again, finding the zeros is finding the x-intercepts, basically. It's finding where the graph, where the parabola crosses the x-axis. Now, how many solutions could you have? What are the options? What are all the possibilities of solutions you could have with an x-intercepts? Can you have more than two? Can you have more than two x-intercepts with a parabola? Think of the shape of a parabola. I'll just draw a few parabolas. Yeah. Okay, how many possibilities are there? There are, for this one, how many possibilities are there? Two, right? Two x-intercepts, right? For this one, two x-intercepts. What about for this one? Only one, right? It just, the vertex is on the x-intercept, therefore it doesn't go below, there's not two, there's just one, right? So there's one solution for this one, there's two solutions for this parabola, there's two solutions for this parabola. Oh, this is interesting. How many solutions for that parabola? None. Right. How many solutions for this one? None. It doesn't cross, right? What about this? Y is equal to, what if I had this? Y is equal to, let me think here, x squared plus 2. Remember how to graph this? There's no b, there's no bx. It's going to be on the it's going to be on the y-axis, right? That's my y-intercept, so it's up 2, dot, over 1, up 1, over 1, up 1, over 2, up 4, draw my parabola. Look, no solution. There's no x-intercept, right? Never crosses. That makes sense? What is this sort of like? This is sort of like the addition of two squares. You can't factor that, right? Because it's an x squared plus something. I can't do x plus the square root of 2 times x, or whatever, like, you know what I mean, square root of 2 times x minus the square root of 2, because it's not the difference. So anyways, yes, so what is this telling us? It's just telling us where the parabola crosses the x-axis, which is a lot of information. If I'm trying to figure out when this thing is going to land in his hand or on the floor, right, then that is finding my zeros in a real life situation. If somebody kicks a soccer ball, right, you know, huge, amazing kick, and if I can approximate that parabola with an equation, I can tell you exactly how long it's going to take for that ball to hit the ground. See what I'm saying? Because I find the zeros. To solve a quadratic equation, to solve a quadratic word problem, it's all about this. It's just finding the zeros. It's finding where the ball lands on the ground again, on the x-axis. Does that make sense? See what I'm saying? So as we move into word problems, we're not going to do that quite yet, but because there's more stuff you have to learn in terms of factoring. But what I'm doing is I'm teaching you, I'm giving you guys different tools to put in your tool belts, right? And these tools are going to help you factor, right? You already know factoring simple trinomials. You know factoring out the greatest common factor, and you know factoring the difference of two squares. We're going to have to talk about other types of factoring as well before you're totally ready to jump into the word problems, okay? All right, so I think that's it. Questions, anybody? Everybody get it? Make sense? All right. Now, what if I had? Let's just do one other thing here before I move. Before I stop. But what if I'm going to just go ahead and have this already factored, right? I'm gonna write one that says it's already factored. Y is equal to 2x minus 3 times 4x plus 1. Okay? Those are my roots. Those are my factored parts of my equation, right? And I'm saying find the zeros. Now this would be a little harder to find in your brain, right? So listen. Okay. So you This one is gonna be a little harder to do in your brain, because, you know, what would x have to be for that to be 0? It's a little harder to figure that out, right? You agree with me? You can do it, but it's just a little harder. So this is where we say, okay, we're gonna find the zeros. You're gonna say 2x minus 3 times 4x plus 1 equals 0. That means if a times b equals 0, then either this equals 0, right? Or this equals 0. So I write it that way. I write 2x minus 3 equals 0, or 4x plus 1 equals 0. So then I add my 3 to both sides. I've got 2x is equal to 3. I divide by 2. So I've got x is equal to 3 halves. So one of my zeros is at 3 halves. This one I subtract 1, I have 4x equals negative 1, divide by 4, divide by 4, x is equal to negative 1/4. Those, whoops, sorry. Those are my answer. Those are my zeros. And I'll put or in there. Typically use the word or because I don't know for sure. I mean, I know with a parabola, those are the two places it's going to cross the y-axis. I mean, x-axis. But I don't know for sure which one is right. Trying to think of whether I want to show you a word problem or not. I don't think I do. I think I'm going to stop. Okay, so that's it for that. So that's pretty easy, right?